Hello and welcome to my shop, and thank you for coming and joining me here for another run at this radio. So just to recap, the radio's working, but its performance is very poor. Picks up one station, maybe two, one anyway, sort of weekly. And we still have tired old capacitors in here. Looking for a chance to retire. Tired capacitors looking for a chance to retire. That would be this one. I thought there were more left in here. Oh yeah, one hidden back here. 1, 2. So what I want to do is figure out what those capacitors are, kind of what they're doing, and see if changing them improves the performance of the radio or not. So who are they? Where are they? So let's pick one. Start with this one here. It's attached to this terminal. I believe. Yeah, this is the beat. And the radio's not plugged in, by the way, in case you're wondering why I'm sticking my fingers in it. But this is tied directly to the negative terminal on the filter capacitors. B minus right here. So this capacitor is attached to B minus. It's not attached to this coil in any way, really. Just found a convenient place to. Now the other lead to attach to ground. The other lead going to a connection here has a fair bit of stuff on it. Sure I got the right thing right here. Well, it's a pin on a tube. It's pin number 1, 2, 3. Pin number 3 on, I believe, is the IF amplifier tube. So maybe we got to stop by the schematic and take a look at pin number 3 and see what's up with that, and we look for a capacitor that goes back to the B minus from there. Yikes. Okay, let's jump on the schematic and see what we can find. Okay, here we are. Now the IF amplifier is this tube, and we're looking for pin number 3. 1, 2, 3. Something went wrong here because this third pin goes straight to the B minus. Okay, something's gone wrong here. So I'm looking at the 12. I'm sure this is the tube I'm looking at. 12SK. That would be this. Well, did I count the pins wrong? 1, 2, 3. Let's look at the radio again. Oh, how do you like that? It's not connected to here. What am I? Obviously not connected to here. That's a terminal for the tube. This is where it's connected. Some other terminal. Oh, there's a little tiny terminal strip in here with one available terminal. That's why there's a bunch of stuff hooked up to it. Okay, so it connects to this resistor. This is a 2.2 mega ohm resistor. Can't be many of those in there. So we'll look for a capacitor tied to a 2.2, and the other side of the capacitor is on the B minus. Okay, let's go back there and look again. Okay, so we're looking for there's a 2.2 right there. And lo and behold, here's a capacitor. Oh, it says 100 something. That's not likely it. Okay, this other end. Gotta be this one? I thought I did this one already. Maybe not, eh? So there's the B minus. And on this side, it's connected to the 2.2 resistor, and there should be more wires coming off. Here's another capacitor that it could be 0.0 something. looks like a 5 there. Could be a 5. That one's connected from one side of the 2.2 and the other side is not B minus. This is, I'm confused now. I've confused myself already. What? It's because the coffee's still being made. Let's go back and look at the radio again. Yeah, there's a, oh. Well, this capacitor's connected to the same terminal. So that's interesting. This one comes all the way back to, it ties to the capacitor frame here. So the two capacitors connected together. And I did see that on the schematic. Two capacitors on the other side of the 2.2 megohm resistor. Let's look again. Right, here's the two capacitors. So I could tell them apart by size. One has 2 digits, one has 3 digits. This is probably a 0.025 here. I found another one of those in this radio. So one of them, the other side connects to the Here we are. Here are the frame of the capacitor. So this is the one that ties to the frame, and this is the one that carries on to B minus. Okay, now we know what we're dealing with. What happens if one of these is bad? Let's look at this one first. So it's from B minus to the AVC line on the grid side of the big resistor. So this one would have a fairly strong effect on the AVC rate of change. So it's kind of integrating the voltage that shows up here, the AVC voltage. But typically you're dialing in, you're tuning in an AM station. It's not fading in and out. And so the time constant arrangement here is not important. So probably does another job, probably getting rid of any RF that's made it back through here, through this resistor and over to this side. Most of that RF that exists from here is going to be killed through this capacitor. But some of it may get through. Maybe this plays a small role in quelling some of that. Now what about this guy? So this is the local oscillator down here, oscillator coils. And yeah, I'm not sure I'm going to be able to sort this out. Exactly what the purpose of this one is. Okay, well let's change this one first. The 0.025, I think it is, capacitor. This one we can identify because it does not connect to the frame of the capacitor. It's the other one. Okay. It's the other one. Yeah, so that's the frame of the capacitor, of the tuning capacitor, and here's the maybe we can call it an AVC capacitor. Let's cut it out of here. The other terminal. Cut that off right at the terminal. It's the easiest ones to forget. Put that there. Just click this here. Good. What do we got? We got a 0.05. I thought this was going to be a 0.025, but it's a 0.05. Let's give it a test. Now the capacitors in this radio have been typical of capacitors in radios. These have been just a little worse than many in terms of how leaky they are. Okay, we're going to put 50 volts onto it, and we're going to watch the eye. I'm going to watch the eye. You should too. And it can't even open on 50 volts, so yeah. Leaky. Now, what happens if you have a leaky capacitor there? Well, that part of the AVC circuit is very, very high impedance, and just a little bit of resistance is going to leak off some charge. So it could kind of drag down the operation of the AVC. So the AVC voltage doesn't get as strong as it should because some of the coulombs are leaking out through that capacitor. Okay, so we'll put a new one in there and try the radio. Okay, let's do a little experiment here. By the way, between the last scene and this one, for you, a fraction of a second. For me, I walked to the grocery store and back. You never know what happens when, between scenes on my videos. You never know what happens to me. So I've got this decade box put in place of the capacitor I've cut out. And I've got it set to 0.02. That was the size, wasn't it? 0.02. 0.05. Okay, well, we'll start with 0.05. We'll operate the radio, try to tune in a station, and then we'll play around with the capacitor value and see what happens. There we go. There we go. Nice day today here. No rain, a little cloudy, some sunshine, but very cool. Very, very cool. Got this guy tipped on a funny angle here. Okay. Seems like a big loss of volume. Now, even though my decade box is set to 0.047, it's not necessarily the size of the capacitor that's in here. I've never checked into this. Never opened this up yet. So let's reduce the capacitance. Getting pretty small now. This last one might even be open, because stuff like that happens. Any size will do it. So that's a 0.2 as opposed to a 0.05. That's like four times the size. Can't hear any difference. And if I disconnect it completely, which one would you want to disconnect? Disconnect this one. Not much happening now. That's my coffee break reminder alarm going off. Not quite what I expected. I kind of expected a lot of swooshing, and maybe if we do this, well, it's still receiving. It's gotten weaker. Maybe the AVC voltage has gone way off. This back on. Almost any size capacitor will do. Okay, let's let me put in the proper capacitor, and we'll look at the next one. Just take a look at the schematic again before I cut this one out. So this is the guy I just did. Now I'm about to change this one, and it's between the grid side of the 2.2, well, we can call this an AVC resistor perhaps, and it's over here, and the other side of it is on the frame of the tuning capacitor. So it's connecting the frame of the tuning capacitor to here. Yeah, I can't explain this one very well, or at all really, so let's cut it out and see what happens. Maybe that'll make it apparent why it's there. Yeah, let's do that. Okay, the cutting out part. We're coming right off this terminal here, which is the terminal to the capacitor frame. The other one is connecting here. Leave a little bit of wire. I can't read the size of it there. It's obliterated by dirt. Let's give them a test. Not sure what you're doing in there, Mr. Capacitor, but let's see how... I find sometimes just the way the schematic is drawn, it makes it very difficult for me to figure out what I'm looking at. I think that's the case with this one. On the other hand, maybe I'm just not smart enough. Maybe not. Okay, here we go. And like the others, it's not able to open on 50 volts, so it's a bad guy. It's a lot of bad guys. There's the pile of them there. Bad guys. Bad guys. Again, bad if they're in a location where a leak is important. A small leak is important. May or may not be the case here. Oh, and what size was that? I'll find out, and I won't. Oh, we're going to experiment here too, right? Okay, not to worry about the size. Let's put in the capacitor substitution box here. Okay, so one goes here, and the other one goes here. Okay, here we are. Okay, and power on. Ooh, careful. Okay, just warming up now. .05 according to this. Pretty sure this is open. Now there's long lead wires here. That's got to be part of the picture. Bit of a heterodyne tone in there. Doesn't sound that abnormal, but it is. Okay, put on any size. We'll put on the proper size. And tune in the station. Oh, that sounds nice. Oh, that's greatly improved. Smaller. Gone. Bigger. The things I might be learning by doing this, let's cut the power here, by putting in the substitution box and trying different sizes, is size doesn't matter as much as I would have thought. I mean, certainly in some places, the size of the capacitor can have an influence on the tonal quality of the radio. Not so much with these capacitors I've been doing. As long as there's something there, it seems to be, that's good enough to make it work. Okay, so point, I think it was whatever it was, I will find out, and I will put in the proper size, and we will test the radio again. Great. Okay, if you don't like blood, look away from your screen. Look at that. Oh my gosh, what did I do to myself? Brought my hand across rapidly like this, and I caught this corner and jammed it right into my hand quite deeply. Oh my gosh, that's bad news, eh? Okay, break time. Break time for sure. Call the hospital. Okay, let's give it a go here. See how we do. Okay. What do you got for me in Niagara Falls? Actually, it's a nuclear power plant called the Bruce Nuclear Power Plant. That's probably supplying most of the electric energy that I have. I was going to say electrons, but that's really a misnomer. Electric energy. 115. Here she comes. There she goes. What happened there? Loud, quieter. Okay. Didn't I leave it tuned to a station? Oh, listen to that. Okay, you heard it this time. You think it's this radio doing that? I mean, it's pretty convincing that radio itself is doing that. Quick. Where's the ticking? Tick, tick, tick. High speed. High speed. So that was a bad demonstration. What I was trying to show you was the same noise you're hearing coming out of here is coming out of there. And you got to hear it right from the start this time. What the heck is that? I don't know. If you're putting comments on my videos and saying, Jim, you know what that is? That's a this. I'm not likely to see it. It's okay. It sounds like a motor coming on and coming off. But the speed is never steady. It's various. It'll stabilize at different speeds of clicking. The only guess I have is it's a static electricity discharge somewhere, and that's a bad guess. Okay, back to what we're doing. Because it's gone away, thank God. Because it's very annoying. Okay, now. What's going on here? We need a lot of volume now. How come we need so much volume? Perhaps the alignment has been affected by some of these capacitors. I really think station's down here. Wow. Well, that last capacitor has made the biggest difference. I'm not even quite sure what all it's involved with. But that's the best this radio's worked. Let's see what else we can get. This is 590. There's nothing below. But let's go. Just some buzzsaw. 590. Hear it? 610 is in there. Should get 680 here. There we are. Unfortunately, there's an interfering signal right on top of 680. And from here, without the dial face, it's a little tricky to know where to hunt. Yeah, not going to do anything else, I don't think. Okay, good. There's only one old capacitor left, and that's this one up here, which carries the sound from the volume control towards the audio stages of the radio. It's a different capacitor from all the rest. It's a molded capacitor. That doesn't guarantee it's any better. So with the lack of volume, and let me get a quiet spot here. That's not very quiet. Okay, so you hear that sound. I don't know how to describe it. It's a hum. To me, that's open circuited grid hum. That's what I would call that. And where could that happen? It was a wild guess. This capacitor is bad. So a combination of bad capacitor making me turn the volume up higher, and a sort of like an open grid beyond this capacitor. Okay, that's enough theorizing. I'm going to cut it out, and we'll do the same experiment. We'll put in variable sizes. Of course, this is a small one, 0.05. 0.05, can I get, well, 0.005. So that's 0.005, so I can go smaller a few steps. Or bigger. Okay, power off here. We're going to cut it out and find out if, in fact, the capacitor is leaking. Wow, it's right. It's right on the. I like to spit on things once in a while. Ooh, where's it connected? Back there a little ways. Let's do this top part first. There's almost no lead sticking out of the. Oh, wait a minute. Wow, okay, there is some lead. So what's happened is the big capacitor and the contact points are close together. So you bring up this big fat capacitor and try to attach it. You have to run the leads back. Anyway, why am I telling you this? It just means it's connected where it doesn't look like it's connected. Until you look. Does that make any sense? Two connection points are very, very close together, but I got a solution for that probably. Well, Mr. Sprague, your molded capacitor, is it any better? I don't know. Let's find out. Let's find out. Hey, who turned this off? 50 volts. What do you say? Look at that. It's not opening at all. You'd think that molten one is better. Actually, this is worse than some of the other capacitors. What happens if you have a leak here? Hey, what happens if the capacitor box I'm using is full of leaks? Probably is. Hey, there's something interesting. Right there. Okay, without knowing the voltage rating of the capacitors inside this box, we can guess it's high. I don't have to go very high with this anyway, necessarily. So we're just going to pick one setting on the box. This is the 0.05 setting. So we'll try that. Here we go. What do you do? So it's opening up, but only part way. So I really need to go in this box, and like this is fun. I'm having fun with this thing. So I'm going to fix this box up, put in new capacitors, and get it calibrated properly and without the problem of leaky capacitors. Because what I'm really doing is I'm substituting various leaky capacitors into this radio. Now we want to put this on here. So this capacitor on one side is the volume control where I just clipped this. The other side is a high impedance grid circuit. And okay, so it's supposed to start out with 0.005, isn't that right? What did I do with it? Yeah, 0.005. 600 volt. You don't need a 600 volt capacitor at that location at all. Okay, we don't know for sure that this is actually 0.05, and we don't know that it isn't leakier than the one I've taken out. We don't know. We just don't know. Here we go. Now, did I leave this tuned on a station? I hope I did. Did I? I don't think I did, though. Let's see. Yeah, I'm very lucky. Where I live, I can walk to a convenience store, a grocery store, and a beer store. All within walking distance. There's the ticking. Okay, so we're right on a very sensitive part of the audio circuit. Having these wires out here. Sound like I'm being electrocuted. No, I'm not. But that's very sensitive. So long wires like this are kind of dumb. Can we tune in the station? Yeah, everything's become kind of... Yeah, don't touch those wires. Turn the radio here. Big loss of volume. That's the station right there. Okay, let's fool with the box now. Getting bigger, bigger, bigger. Didn't help much. Smaller, 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 smaller. Ooh, he's humming like a son of a gun. Ooh, there's a big hum in the speaker. Can't hear it. Hum's a little bit reduced by the... This is not working out well. Okay, I think it's a false test. One of the things about this capacitor, how it was installed, it was installed like this. The lead's back like that. What is that sound? Peanut, what are you doing? You know, you see my other cats in the background there. Hey guys, what's up? Hey. Yeah, very, very responsive. Yes. Very responsive cats. Okay, so I'm going to put in the proper capacitor. What I was leading up to, leading up is a good word for it. I'm going to try to put in one with the shortest leads possible. Pretty tight spot in there to get it right in there. The contacts are right next to each other. That's one. And the other one's right here. Okay. 0.005. Brand new. You know what might have gone wrong with that test? This thing's leaky. And maybe that's undermining it. Okay. That's good. I'll put in the capacitor here. Okay, here we go. Got the little capacitor in there. Come on, radio. So I've now gotten rid of all the obvious kind of problems that happen with these radios. There can still be lots more wrong in here. I haven't tested the tubes, so it could have weak tubes in it, or a weak tube. And yes, some of the small mica capacitors, one of those could be bad. I don't know. I haven't tested them, and I tend to ignore them all the time, actually. Once in a while, you have a failure that forces you into discovering a mica capacitor is responsible, but for my experience, they are extremely reliable. Okay. Okay, got the volume back. Where's the station? Sports talk. $680. So as far as radios are concerned here in my shop, this one's working at this point. So it's picking up some stuff. It's certainly not the best radio I've had operating in here, but it's not dead. And if I took it out to another location, as I mentioned quite often on these videos, out of my horrifying shop, somewhere else in my house, or better yet, right outside, a radio that's performing the way you hear it here can be performing surprisingly well when I get it outside. But you know, the best AM radio I tune regularly is my car radio, my truck radio, actually. Once in a while, I'm sitting in a parking lot, my wife's in shopping, I'll flip around the AM radio stations just to see, what can you really hear. Of course, my car is away from houses, it's sitting in a parking lot, so there's not much interference. Oh my gosh, there's all kinds of stations that can be heard. So I gotta put this in the car. That's right. I'll talk to my wife about that later. Okay, thanks a lot for watching. Tomorrow we will go through the alignment procedure with this radio, and then we'll find out at that point really how well it's working. Still haven't tested the tubes. Thanks a lot for watching, and I'll see you on the next video. Bye.